Okay guys, for this lesson, we're going to learn about a relation and a function. We're going to learn how to identify if a relation is a function and then also recognize the domain and range of all relations. So a relation is simply a set of input and output values, and normally you see these as ordered pairs. So anything can be a relationship. No special rule is needed to be a relationship. So it's like the big umbrella is a relationship, and underneath a relation is going to be functions and not functions. We will specifically look at functions for this lesson, but just know that anything can be a relation. Here are different ways that we're going to represent relations and functions. We're going to note them as set notation or ordered pairs. Then we can see them in a graph, in a table, and a new representation you may not have seen, and that's a mapping. Now, all four of these representations are the same relation. So you can see we have 2, 6, 3, 5, and so forth, and that is the same values as in our table and our graph and our mapping. When we apply a special rule to a relation, we create a function. And the basic thing you need to know about a function is that each x value or element has only one y element. So in this equation, y equals 2x plus 1, when I put in my inputs, my x values, and I say 2 times that value plus 1, my output is going to be the same every time I put in that particular input. For example, if I plug in 2, as we have here, if 2 is my input, 2 times 2 is 4, plus 1 is 5, and I get an output of 5. If I plug 2 in again, I'm going to continue to get 5 as my output. If I put 2 in and I got something besides 5, another number, then this would not be a function. So each input can only have exactly one output. We can look at a vending machine as a function where if I punch in a code for, let's just say that this Gatorade, this yellow Gatorade is D1. Every time I click D1, I'm going to get the yellow Gatorade. So the D1, my input, that's like our X, and the output is like the item that I expect to get. If I put in D1 and I get a bag of chips instead of the yellow Gatorade here, then this would not be very functional. So each input, my code, D1, can only give me one exact output, a particular item in the vending machine. Now let's take a look at some new vocabulary words. The word input you are familiar with. This is also called the domain of the function. So my domain are the codes that give me my output. And another word for output is range. So you need to associate input, usually your X value, with domain, and output, typically the Y value, for range. So my range, or all the items, is the things I get out of this function. My domain are all the things I put in order to get out what I want. So the input is your domain. And again, this is usually your X values, and your output or range is your Y values. So in this example, my input A1 gives me an output of water. My input of A2 gives me out a Coke. My input of A3 gets me out a Pepsi, and so forth. If I click A1 and I get a Pepsi, this is not a function. A1 can only give me out water. So my domain would be A1, A2, A3, and so forth. Those are your inputs. Your range are the things that you get out. The water, the Coke, the Pepsi, and so forth. So again, your domain is your input and your range is your output. Here are a few other terms that are associated with domain. If you want to pause the video and take these notes down in your notebook, then pause and we will continue. So here we have one representation, a graph, and this is a very popular test. It's called the vertical line test. It lets us know if our relation is a function or not. In order to test to see if a graph is a function using the vertical line test, you simply draw a line down a vertical line, and if you intersect more than one point, then this is not a function. So anywhere in the graph, if I use that point, it's only intersecting once, but over here it intersects two, so this is not a function. In this example, no matter where I draw my vertical line, I'm only intersecting one point, so each x value had one y value, so this is a function. In example 3, I can draw a straight line, and this is a function. Okay, let's take a look at 3 more examples. So you try to determine if you think 4, 5, and 6 are functions or not. Okay, so number 1, you can see this vertical line does not pass the vertical line test. If I go down it, it hits every point, so this is not a function. Here we have a sideways parabola, and it intersects more than one, so this is not a function. Here, if I draw a line down, it intersects one, so this is a function. So that's called the vertical line test. Now let's look at a few more representations. We have function tables and we have a mapping. So we know that in a function table, the x values are input, and f of x or y, these are our outputs. In a mapping, these are your inputs, the x's, and these are your outputs. So this is like 5, -3, 5, -2, 5, -1, 5, 0. This is just another way to write a set of ordered pairs. So we need to first just look, and let's get a different color so we can see it. Let's first just look at the x values. If the x values do not repeat, we can immediately say that this is a function, because this -3 only has one output. It only goes to 5. This -2 only has one output. This -1 only has one output. This 0, one output. This 1, one output. And this 2 has one output. Now, the outputs can all be the same. It's just like if our vending machine was loaded with just waters, no matter what code I put in, I would get a water. This example, I have 5 with an output of -3. It also has an output of -2. It has more than one output, so this is not a function. Let's take a look at these ordered pairs. Again, we're just looking at the inputs at the begin with. And I notice I have a -1 repeated. I have -1 going to 3, and it also goes to 5. It can only go to one value, so this is not a function. Okay, let's take a look at just some concepts. So again, this is my input, and it can only go to one output. So if I take a look at an email address, if you type in an email address, how many different people is it going to go to? It's just going to go to one person. So this is a function. This is one unique email address. What about an individual and an email address? Well, personally, I have many email addresses. So if I write my name, Miss Thomas, I could list all my email addresses and you wouldn't know which one I was referring to. So this is not a function. Here we have a driver and a driver's license. So this driver usually just has one driver's license. So because you can, but what if you live in a few different states? So driver to driver's license. Maybe I have, and even in my wallet, I have my old expired driver's license. So Ms. Thomas has a current driver's license and an old driver's license. So this is going to be not a function. But now if I picked up somebody's driver's license, it would just go to one driver. So this is a function. A locker combination. So if I give you a locker combination at the beginning of the year, it's going to one student. So this is a function. But what if a student has a locker combination in the hallway and maybe in the gym? They would have two combinations. So a student could have two combinations. So this is not a function. Okay, now let's talk about, again, domain and range and if it's a function or not. So I am going to get a darker color. So I look at my x values, none of them are repeating, so this is a function. My domain, I'm going to list each x value because that's your domain. My range, my output, my y is 7, and if anything repeats, you just list it once. Here we have two 4s, and they give me a 2 and an 8. Those are two different outcomes, so this is not a function. My domain is going to be 4, 5, 6, 7. My output is 2, 4, 6, 8, and 10. Here, none of my x's are repeating, so this is a function. My domain is 1, 2, 3, 4, and 5. My output is 1, 2, 3, 4, and 5. Here I have a 7 and another 7. They have two different outcomes, so this is not a function. My domain, I'm going to write in numerical order, 4, 5, 6, and 7. My range is 1, 2, 3, 4, and 17. Okay, let's look at a mapping. So this 2 has two different arrows. I don't even care where they're going to, but I know that it has two different outcomes, so it's the same as the 4. So this is not a function. So our domain is 2, 3, and 4. And my range is 7, 8, 9, 10, and 11. On number 6, each of these inputs has one output. So this is a function. My domain is 5, 8, 12, and 14. My range is 1, 2, 3, and 4. On number 7, it looks like each input has its own output, so that's a function. So our domain is 7, 8, 9, 10, and 11 with a range of 14. Okay, now let's get into graphs. So this is going to be a little abstract thinking. So you can see I have infinities going in all at the ends of my number lines. And so my domain, again, is your inputs. So this graph has arrows on the ends, so it can go forever to the left, so negative infinity, and it goes forever to positive infinity. The same with our range. And remember, when you're using interval notation, that you put the smallest number first, or actually any notation. Let's skip to number 9. We can see that the domain, this is constantly getting wider left and right. So my domain is negative infinity to positive infinity. It goes down forever and it goes up forever. So my outputs are all real numbers as well. Domain, we have arrows on the end, so the domain is going slightly left and slightly right. The range is going down forever, but it has a ceiling here. It stops at the 5, and we're going to use a bracket. And let me back up for a second. This is a function, function, and function. Okay, in these examples, our first number 11, we can see that the graph does not pass the vertical line test, so therefore this is not a function. In the domain, it can go all the way till x is negative 3, and it continues forever to positive infinity. The graph can go down to negative infinity and up to positive infinity. Number 12, this graph passes the vertical line test, so it is a function. How far left our x values is negative 4. and then it can go all the way to positive 4. And then how far down does the graph go? It goes to 0, and then it goes up to positive 4. So that is the range. Here, our circle does not pass the vertical line test. It is not a function. And how far the x values can go from -4 to positive 4. Our y values go down to -4 as well, and up to positive 4. And here's the last set. So this parabola passes the vertical line test. It is a function. And our domain, our x values, go to -3, but -3 is not included. And then it goes over to positive 3, not included. How far down does the graph go? It goes to -5, and it is included. And then it goes all the way up to positive 4, and this is not included. Number 15, our graph passes the vertical line test. It only intersects at one point. It is a function. It goes all the way to -5 to positive 1. So that is our domain, -5 to positive 1. These values are included. Then how far down does the graph go? It goes to -6. It is included. And it goes all the way up to positive 3, and this is included. And our last one, this line passes the vertical line test. It is a function. The graph extends all the way to -4. It is not included. It's an open circle. And then how far right does it go? It goes to 4, and it is included. How far down does this graph go? It goes to -1, 2, 3, -4. It is not included. And then it goes up to 0, and that is included.